Welcome. Now in this session, we'll see how to do the differentiation and integration in Simulink. Let's start. Let's open MATLAB. This is MATLAB. Now to open Simulink, I can either click on this Simulink tab or I can type here Simulink. Let me click on this tab this time. We know a window pops up that looks like this. So a window pops up that looks like this. This is the window that appears after you click on the Simulink tab. Now I will click on the library browser. Now the goal here is to do this differentiation. Let me start with the differentiation. Let's see how to obtain the differentiation of a sine wave. So to first I must have the sine wave block, then a differentiator block, and to visualize this I will have a scope block. So let me bring these blocks. So I will click on the library browser, simply Simulink browser. Now, see, if you remember, if you don't know where to find a block, means in which toolbox the block will be contained. So to do that, see, I have opened this Simulink browser or simply library browser. So if you don't know where to find a block, any block that if you don't know, suppose it appears like to you this way, and you don't know where to find this, you can type the block name here. Just type it and hit the search button. Just type the name here, and for example, I want to find the sine wave here. So I can type sine wave and hit it. This will try to find this block in the corresponding toolboxes. This will give me the information after it finishes this searching operation. You can see this is one way to find. If you don't know where to find the block, remember this. If you don't know where to find, you can just click on this. You can just type the name of the block, and you can see there is sine wave function, there is sine wave, there is chirp signal, there is sine wave in DSP block, DSP toolbox. There are different sine waves available to you in different toolboxes. See, here I know where to find it. I know already it is contained in sources. I know already. So let me bring it here. So I add it to the untitled model. So it adds a block to the untitled model. You can check it. That is the sine wave block. You can check it. All right. So the next block I need is the differentiator. So to find the differentiator, let me switch back to the Simulink library. So this is the Simulink library. Now you can either type the there's differentiator here, or you can, I know it already, that's a commonly used block, or that will be contained in continuous. You can just go back here, you can see the derivative is here. So you can right click on it and add block to this model. You can check it. Now a block is added to this untitled Simulink model, that is du by dt. This is the derivative. So whatever is input it will take the derivative of that. This time we want to perform the differentiation of sine wave. All right. Now I want to see the result also. So let me switch back to this Simulink library. So this is the Simulink library, and I want to see the result. See, that will be contained in sinks. So I want to add this scope block to this. So this is a scope block. And to show you the result, let me switch back to this untitled model. Now I will connect to these. So this is connected to this. This I want to connect, but I want to see the input as well as output simultaneously. So I want to see the input as well as the input wave of which I want to take the differentiation, and the output means the differentiated output. So let me click on this. Let me make this window bigger. So I can click on this, right click on the scope block. Then after that, I can click on the signals inputs. There is number of inputs, and let me just have two inputs here. So I want to see the input as well as output simultaneously. Now input here is the waveform of which you want to have the differentiation. Output is the differentiation, right? So let's call this signal as input. So the input is the input waveform, and the output is differentiated. All right, so this is the differentiation of this. All right, so let me run it. So let's run it and see the result. So after you run it, double click on the scope so you can see the result. Let me share the screen with you. So this one is the input, another is the output. To see which one is input and which one, you click on this configuration tab again. You know, a window will pop up. A small window will pop up that looks like this. Now then you can click on the display and you can see show legends. Apply it and see the result. Let me go back to the scope window. This is the scope window. You can see yellow one is the input, that's the sine wave, and we know the differentiation of sine wave is cosine wave. Again, remember, why is this not starting from directly 1 here? Why is this gap here? This is due to the number of points, less number of points that's available to you. So how do we resolve that problem? We go back to the model. So this is our model. And go back to this, click on the configuration button. After you click on this, a window will pop up that looks like this. And you click on solver details and you set the maximum step size. You can set it to 0.001. You can set it to lower value also. So this is what appears there, and you let me switch back to the model that I have just built. This is the model, and I click on the run. Now if I click on the scope, now you can see the problem is resolved. And the problem occurred only due to the less number of points that were available to us, to MATLAB actually. All right, so you can see the differentiation of sine wave is cosine wave. This is how you take the differentiation in Simulink. This is one example. Now let's take the differentiation of ramp. Let's see what will be the differentiation of a ramp. So let me bring the ramp block here. So I have to click on the library browser. After I click on the library browser, this appears. And to where will be this ramp? It will be in sources. So let me bring, this is the ramp. Click on, right click on it and click on add block to the model Untitled. We haven't named this model yet that we have built. Let me switch back to the model. This is the block that I have added. I will delete the sine wave now. And this is what I have added. All right, now let me run it and to see the result. You can see this is the result. The result looks like this. My input is the ramp, output will be, we know the differentiation of a ramp is a step. Differentiation of a ramp is step signal. You know that differentiation of ramp is simply step. You might have already studied in it, signal system class. So the differentiation of ramp is a step. We know it's very simple because the slope is constant, so it will be always constant. Slope of this ramp is constant, so it will be a constant signal. This is very simple. No need to worry. Right. So this is how we take the differentiation. Now let me show you how to take the integration. Now let's start with the integration of this ramp. All right. So to do the integration, I have to bring the integrator block from this library. So let me delete the differentiator and bring integrator block. So I have to click on the Simulink library browser. Now this appears there. You can the block is in continuous on this continuous tab. You click on the continuous, you can see there is one block named as integrate here. Now right click on it, add block to the model. You can see a model is added to our a block is added to this rather. This is how I added the integrator. Now I'm performing integration of this ramp and I'm checking both input as well as output simultaneously. So I will run it. So you can see what will be the first of all, before I show you the result, what will be the integration of ramp? We know the integration of ramp is in this parabola. Actually, it's a parabola, I mean it's t square. If the input is t, output should be t square because the integration of t is t square. All right, let me show you the result. This is the result. You can see the input is ramp, the output is parabola. It looks like a parabola. Now you can increase the simulation time here. Let me increase the simulation time to visualize this better. Let me change the simulation time to 50. So the simulation time is 50. You can see the result. And let me share the screen with you. This is the ramp. Although ramp is increasing slowly, it is increasing because its maximum value will be 50 only. But what will be the value of this? What will be the value of this parabola? If you do the integration of t, that will be t square by 2. t square. See, what is the final value? It is 50. So the last value should be 50 square divided by 2. How much is 50 square divided by 2? That's 1250. You can check the answer is correct. It is 1250 here. The answer is 1250. That's why it shows the yellow, means the input is slowly increasing, because we know the maximum value of the ramp here is only 50. But the maximum value of the integrated output, means the output should be 50 square divided by 2. That is 1250. You can see the answer is correct. So that's so it's giving you the correct result. Please interpret the results yourself. What is this input and what is the output? What should be my input and what should be my output? Please have a look at that. So the ramp final value of ramp is 50. So the final value of integrator should be t square by 2. T is 50. So the answer should be 50 square divided by 2. That's 1250. All right. I hope this is clear to you. Now let me illustrate one final example. That is how to take the integration of a sine. How to take the integration of a sine. So to bring back the sine, let me switch to library browser. So I will bring back the sine view block, click on the source, then click on this sine view and add this model to this, and let me show you the model. Now we have added the sine view, and let me delete this ramp. Right. So this is the sine wave. This is our sine wave. Now I want to perform this integration of this sine wave. So if I hit the run button, let me change it to 10 only. Instead of changing it to, let me keep the simulation time only up to 10 and stop taking it to 50. You can keep it 50 by the way, there is no issue there. Now you can see the result. Now let me show you the result. Now you can see the integration looks weird. Although the input is sine, but the output does not look cosine. What is the integration of sine wave? It is minus cos. If you remember, integration of sine is minus cos, but this doesn't look minus cos. This doesn't look minus cos. Now what happened to this? Now to illustrate this, let me switch to a window first. Let me illustrate this. What happened actually there? We integrated this. So we know the integration of sine is sine theta. Theta is minus cos theta, right? But we know the integrator actually adds this one constant of integration, that's k. And MATLAB assumes this constant of integration is actually 1. MATLAB, I think the integration of sine is cos or minus cos. So MATLAB assumes that the value of this integrator is, I think, 2 here. So it takes the value of this arbitrary constant itself. It doesn't let you choose. So how do we resolve this problem? What we can do, I think so 1 here and I don't know how much it takes. Have a look at the output waveform, you will get the value of this constant. Now MATLAB assumes it is equal to +1 here, let's suppose. So what we can do, we can add a constant of integration to this, means we can add the initial value to this -1. So that will subtract to this, so the output will be minus cos. Let me show you how to do that here. I hope you understood. We know the integration of sine wave is minus cos, but we know the integration is actually involves one more factor. That's the constant of integration. And this is that k. And MATLAB assumes it's equal to 1 here. MATLAB takes it equal to 1 here. Now to resolve this problem, what we can do, we can add an initial value of this integrator that is equal to -1. So how do I add the initial value so that this k and -1 get us cancelled and we get the desired result? Now let me switch back to the model. If I double click on this integrator, a window pops up that looks exactly like this. That is this. Now you can add the initial condition here and you can say -1. Initial condition means initial value. So if you say apply, and let me switch back to the model. This is the model, and if I run it, and if I double click on this, you can see now the result looks like this. This is our result. Now the input is sine wave, output is minus cos. You can check it, it starts from minus. And we know cos starts from 1, but minus cos will start from -1. You can say now this is correct. I hope they have got the idea how to take the integration of sine wave MATLAB. All right, I hope this is clear. Now I want to check one file. You can take the integration of ramp, it's parabola. You can take the differentiation of ramp, it's parabola. You can take the one more view I want to take the integration of is the step signal. If the input is step, what will be the output? Now we know if the input is step and you have an integrator in between, what will this integrator do to the step? Step means it's a constant voltage. So the integrator will try to add these input values, that is the step value. So the output will be a ramp signal, you know that. So let me add a step to this, and you can see I have added a step signal here. So this is our step. After I add step to this is the step signal. Now we know the integration of step is ramp. Now to show you the result, let me run it, and you can check the integration of step is ramp. So the integration of step is ramp. You can see the ramp starts from 1 and it starts increasing, and step starts at 1. You can change this step signal, means it can start at 0. Let me show you that in a second, but here the step starts at t equal to 1. You can see the integration also starts. So this starts integrating the values and it increases. As time reaches 10, the output value is equal to 8, 9 actually here. All right, let me show you how to change the step instant. Let me go back to the model. Now this double click on this step, a window pops up that looks like this. You can check. Now the step time is set equal to 1 here. You can set it to 0 here. So you can set it to 0, apply. After you have applied this, you can see the model is this, and now run it. After you run it, you can check the result. You can see the step now starts at t equal to 0. You can see the step starts at t equal to 0. It becomes 1 equal to t equal to 0. Then the ramp starts. You see, why does it start at -1 here? What is it? Because I haven't changed the initial condition. Please remember that I haven't changed the initial condition in our integrator. Let me do that. Set the initial condition again to 0, because this was set to the previous for sine wave block. So I haven't changed the initial condition yet. You can see this is the, so it starts with ramps. The output starts with 0, then it go as at t equal to this becomes 1 minute step signal, and this output starts increasing linearly. Meaning the integrator output starts increasing linearly, and you can see when time reaches equal to 10, the integrator output is equal to 10. Integrator output is 10. Okay, let me go back. The model, you can see the model here is represented, the integrator is represented by 1 by s. If you know the transfer function of the integrator from your signal system class or from control theory, you know the integrator or maths class, the integrator transfer function is 1 by s. That's why MATLAB represents it by 1 by s. This is also a capacitor. You can model it as a capacitor. You can say that this is our capacitor whose capacitance is equal to 1. So the capacitance is equal to 1 here. All right. Now, finally, I want to conclude this with the differentiation of step. I want to do the differentiation of step. So let me delete this and bring the differentiation block from this continuous. You can add it derivative to the model. Now I have added it. You can see the model is this. You can connect it here. All right. Okay, so this is the derivative. Now let me change the step time. First of all, let me change the step time to show you. Let me change the step time should be at 2 minutes. It should have a step at t equal to 2, not at 0. And the step signal should start at equal to, not at 0. All right, let me show you the model. So this is the model, and if I do the derivative, so I run it. Let me show you the result. All right, I hope. Now, before I show you the result, what's the differentiation of, what is the differentiation of step? It's actually 0 everywhere, only at one place where the step takes place. it becomes impulse there. Let me show you the result. Now you can say it is indeed an impulse at t equal to, because the step is at t equal to, it's an impulse. You can say the value of this impulse is 7 into 10 is per 30. So I hope this qualifies as a step here. So the output is step here. You can check the output. Now you cannot see the input because input value is 1 actually here. So that becomes almost 0 for this visualization. So the output is an impulse. So the differentiation, we know already the differentiation of a step is impulse. I hope that 7 into 10 is about 13 qualifies as a impulse. I hope this is true. All right, let me end this session here. In the next session, what we are going to do, we are going to learn how to solve a differential equation using these integrator blocks, how to solve a differential equation graphically instead of solving it analytically or mathematically. How do we solve this differential equation in this graphically in Simulink? All right, let me end it here.